Okay, so what we want to do here is we want to find the domain of the following rational functions. So what we want to look at is you want to ask yourself, okay, well, what are the x values you can plug into this function and the function be defined? So for rational functions, what we want to do basically is look at the denominator and see if any values are excluded from the domain. Now we already know that we cannot divide a number by 0. So if you're thinking of, for example, this first problem, what number can you not plug in here? Meaning, what number makes the denominator equal to 0? So the question here is, when is 67 equal to 0? Well, notice that 67 is not equal to 0. It never is. So this means that there are no excluded values. No excluded values for this one. Because there isn't even a variable in the denominator. So so what would we say? Well, there's no excluded values. Then the domain in set notation would be, it's a set of x values such that x is in the set of real numbers. Okay, so that's how you would write it in set notation for the first one. Now the second one here, we have, actually this should be f of w, sorry. Okay, so for the second problem, it's a little bit different because notice, if you ask yourself the same question, when is the denominator, which is nw squared minus 4, when is that equal to 0? This you actually can solve. So the first thing you need to do is you need a factor. So 9w squared minus 4, you might remember, that's a difference of squares. Okay, now if you forgot how to factor a difference of squares, remember, that's when you have a difference of two terms that are perfect squares. So how do you factor this? Well, you can factor this as follows. Okay. So then if I factor 9w squared minus 4, what would that look like? So we open up two parentheses, and basically you just get the square root of each term. So the square root of 9w squared would be 3w, and then 3w. And the square root of 4 would be 2. So I'm going to have a 2 and a 2. And then you'll have a plus and then a minus. And the order doesn't actually matter. It could be minus and plus, or plus and then minus. Okay, now, after you have that, then you set each one of these factors equal to 0 and you solve. So I'll set 3w plus 2 equal to 0 and 3w minus 2 equal to 0, and I'll solve. So here I would have 3w equals minus 2. So w is minus 2 divided by 3. And for this one, I'll have 3w equals to plus 2. So w is positive 2/3. Okay, so these right here are my excluded values. Okay, so now what's my domain? So for the second problem, the domain, how would I write this in set notation? So this would be the set of x values such that x cannot equal to positive 2/3 or negative 2/3. So you can write this in condensed form as plus or minus 2/3, like that. Okay, now for the third problem here, same thing. You want to take a look at the denominator, which is x squared minus 3x minus 10. Set that equal to 0. And then you want to factor. So here it's a little bit different. So we have a trinomial. So we have, we know that we're going to need an x and an x here. And now we're looking for two numbers that multiply to 10 and sum to minus 3. So what are those two numbers? Well, that would be minus 5 and plus 2. Because minus 5 times 2 is minus 10. Minus 5 plus 2 is minus 3. And then you just do the same thing we did in the previous problem. Set x minus 5 equal to 0 and x plus 2 equal to 0. So then if we solve these, I would get x is 5 and x is minus 2. So then the excluded values are 5 and minus 2. So then what would be the domain? So the domain is a set of x values such that x cannot equal to 5 or negative 2. And that's it.